Welcome back. This is lecture 17. This is the last lecture in our course. All the relevant files are in your Dropbox and your Blackboard. In the previous lecture, we saw how to use sockets to reach out to servers. We were the clients in the previous lecture. In this lecture, we will learn how to write a server, that is, install a server using Python. Writing a server is quite different from writing a client. A client typically establishes a connection, makes a request, and processes the response. So what does a client do? Client will establish a connection with a server, will send out a request, and whatever response you receive, process it. On the other hand, what is a server? At a low level, that is at a low level programming, server consists of listening. Okay, a server is just waiting. Server has to just keep listening for incoming connections. So there is a particular port you have to set aside for the listening of incoming connections. Then the server should be creating a socket to manage each such connection. So whoever connects gets a socket to correspond with the server. And then following the chosen network protocol, you have to communicate with the client. Python provides a module called socket server module with some convenient tools. Now, TCP stands for Transmission Control Protocol. It is a protocol used for establishing connections on the internet. So, the socket server has a class called TCP server. This class handles all the details of listening on a specified port for incoming connections and creating dedicated socket for each such connection. So remember, a server has to listen, create a socket for each client, and then communicate. Okay, so TCP server will do two of the three things needed. One, it is going to listen, and two, is going to create socket for each client connecting towards it. The precise interactions that should take place once a client has connected then needs to be customized. So now we have connected the client. What next? We need a second class which will handle each connection. Okay? So our socket server module in Python has a special purpose class that inherits, so that is a child class of base request handler. So we will design our own class which will be a child of base request handler. Base request handler has its own handle method, but because we are writing a child class of this class, base request handler class, we will override the handle method. So when we are working with the handle method, by then the TCP server should have already initialized a socket. That socket is identified self.request. Self.request is the socket, okay, used for communicating with the client. Note that in this case, the server's socket uses the send method to send data from the server to the client. So you are going to use the send method. Server's socket will use the send method. All right. So you will see the code soon enough. Likewise, the receive method is used to retrieve data from the client. The port can be whatever number we choose. Remember, port numbers go from 0 to 65,000 some odd. All right. Now, some of those are reserved for special protocols, like 80 is for HTTP and so on, right? So we don't want to use those ports which are reserved for special protocols, but choose some arbitrary number. Typically it is fine. Okay, I use port 9000 typically. You can try different ones, 9003. Okay, chances are it's not reserved for anything else. Okay, now the handler class is the name of the customized handler class. So we are defining a handler class. Okay, so in for each um, for each program, what we expect our server to do will be reflected in the handler class you decide. Okay. Now, lastly, the serve underscore forever method, when you invoke it, your server starts to run. All right. We can terminate the server by interrupting the Python interpreter. So you can um, uh, use Control C in your Python interpreter and thereby stop the serve.forever method. All right. So here is a code to design an echo server. So echo server, what should it do? Is just some server. Whatever message the client sends my server, I will echo it back. That's all it is. Okay, it's a simple server. So to begin with, we are going to use the socket server module of Python. From there, import TCP server and base request handler. Remember, what is TCP server good for? It is good for listening to, that is waiting for a client, listening, and then create a server, create a socket for each client. All right. Base request handler. What is this good for? This is what is used for us to design a child class which will handle any request as we tell it to. Okay. So we have imported these two classes. Now you are defining class echo handler, which is a child class of the base request handler. So notice I am not changing any of the um, instance variables. I am simply overriding the handle method of my parent class. What is handle method going to do? Self.request. This is, remember, the socket. Whatever it receives, I'll call it message. So I'm allowing 1024 characters. Okay, I'm calling it message. Whatever my socket receives, I call it message, and I'm sending that same message back. That's all my echo handler is going to do. Okay. Now, so that was the class I defined. Now use this class to set up your server. Remember, TCP server, what does it do? Sets up a server. I have used localhost because I'm going to use my computer as a server, and I'm going to use my computer to as a client also. Okay. Localhost 9000 is the port number I chose. You can choose whatever number you like, less than 65,000. Okay. Try and make sure your number you choose is random enough that it's not one of the reserved ones, right? So I'm opening this server and I'm going to handle the clients using echo handler. Okay. So that object that I've created is going to now serve forever. That means my server is activated. So here is the code, the same code I explained to you, server. It is in your Blackboard and Dropbox. All right. Now, I'll run it and it's now started. It's waiting. Okay. The server will wait as long as we let the computer run. Okay. Now I want to open another Python shell. If you are on Windows, then you can again click on your idle and a new shell will open. Look, the shell first that we have is busy right now. We can't use it. So you will have to open another shell. Okay. For Windows, it's easy. You just click on the idle app wherever it is on your computer and it will open another. For Mac, I have to go to the terminal, right? If you have Mac, go to the terminal and ask it to construct another idle, right? So idle and enter, and that opens another. So look, this is running, okay? Okay, so here I have another shell going. So I am going to approach my server, which is running now. So the left hand side is my client, right hand side is my server. Okay. Now look, your server is running on your computer right now. You could, by the way, use some other computer and approach the server. In that case, your command will be slightly different. I'll explain how. So now here I'm going to be a client. So I will say from socket import socket. So clients need socket, right? So let me call my socket, the one I will construct. I'll call it echo. Is just a name, socket we have created. Now I'm going to connect to my server. This is my server. Okay. So I'm going to connect. So let me keep it here. Echo.connect to the server. So I will say local host and I have to use the same port. Now here is the catch. If I were to use some other computer, then I cannot use localhost because then that computer is the local host. So if you're using some other computer and you want to connect to the server that is sitting in my computer, you need my computer's address, IP address, and that's where IP addresses come into play. Okay. Right now we are working within one computer, but you can try. If you have two computers, run a server in one computer and from the other computer run a client, and instead of local host, give it the IP address where the server is running. Okay, so now here is my client trying to connect to my server. Connection has been established, no problem there. Now let me send a message, any message. Okay, hello, how are you? Okay, so I sent a message. Oh, 19 characters were sent. Let me see what I received. Let's say I'll give it 1024 characters, and don't forget to decode it. Oh, I forgot to encode it. Let's see how it goes. Aha, it gave me the same. In other words, the server I constructed was very good as an echo chamber, right? It sent back the same phrase. All right. So the return value is the number of characters you successfully sent. This is provided by the socket, not the server. If we try to echo a second message, we will find that the connection has been closed. Okay, as long as the echo server is executing, we could create a new socket and echo.